Hi folks, so this question here we're going to be doing is the 2021 section B question B3 from the Leaving Cert, as I said, 2021, okay, it's the higher level exam. The question here is actually based on axonometric projection. So with any question, we're obviously going to read the information and then get straight into it. So it says here, the image on the right shows a table tennis table. The figure B3 shows an incomplete trimetric projection using the axonometric axes method of a similar table tennis table. Okay, so by trimetric, basically what they're saying is all the angles in here in the triangle ABC, all those angles inside here are all going to be different. The elevation end view are shown in their required position. So we've got the elevation here, end elevation here. What we have to do is we have to draw the axes, X, Y, Z axis, and the scalene triangle ABC. Part B, draw the elevation end view orientated and complete the trimetric projection. So to draw this, and then get the trimetric view in here, or the 3D view essentially, which is going to look like this. And then part C, determine the true length of the diagonal along the top surface of the table. Okay, so to start off with the question, we just have to obviously look at the information given to us. So part A, draw the axonometric axis X, Y, and Z. So the X-axis, the Y-axis, and the Z-axis. The Y-axis is going vertical. The Z-axis in relation to the Y-axis is at an angle of 110 degrees. And then they don't give us the angle for the X-axis, but what they do tell us is from the origin here, right in the middle, if I come down here, and then that line there connecting to A is 50 millimeters, and then an additional 40 will get me C. Therefore, when I have C, I can connect C up to B. So that's where we're actually going to start with this, okay? It's creating the X, Y, Z axis, and we're going to get the scalene triangle ABC, okay? Now, orientating that in the page, I have to consider where I'm going to be putting it. I'm fitting this on an A3 page, which it should fit on. I've got the elevation over here, and if you look at it, it's obviously a lot longer than the end elevation. So if you consider starting maybe in the middle or just right of center, so if that's my pencil on my page there, I probably want the Y line, the Y axis, to be a little bit just to the right of that, okay? Just to give myself enough room, okay? It'd probably fit fine in the middle, but I'm just going to go a little bit to the right of that. So that's the middle of my page there. I'm going a little bit right to that, so there's the middle, just a little bit to the right. Put my Y-axis out here. Okay, and I also have to consider then, if you obviously consider down here, really close to where my hand is on the screen, is the bottom of my page there, as you can see it there. Okay, so I also have to consider I have to have enough room that this is going to fit in the page. So I'm going to come down just a little touch more. I'm going to say right there at this point there is my origin. Okay, so from there now I have to get my protractor, which I don't have on me. So using protractor, I'm going to measure a distance, or an angle, sorry, of 110 degrees from my origin. So 0 reading around to this way, 100, 110. So there's my 110 marked. Now I'm going to put in my next axis. Okay, there's my next axis drawn, and then now I want to set up for my x-axis. So from the origin O, I'm going to do a line down. So I do it now, and on that line down, I'm just going to do a very light line across there. You barely see it on the screen, but from the middle here, I'm going to measure 50 to the left. And I'm going to measure 40 millimeters to the right. But once I've measured a 50 to the left, I can just mark that up there from this little 50 mark, marked it on the line there, and from that there I can now draw in the baseline of my scalene triangle, and where the 40 millimeter mark was here, once again I can mark that there, and on that line there now I can draw in my x-axis. Okay, now that I've got my axes, I'm going to label those. So this one up here was my Y. I want to label this one out here as my Z, and this one out here is my X. Okay, I've also got A here, C here, and what we're lacking then is obviously B at the top. So to find B at the top, just do a little bit of sliding set squares here. So I'm going to set up my 45 degree one, on my x-axis. This is what I like to do it when I'm in class. I'm going to rotate it like this, and just go out of the way. Now I'm perpendicular to the x-axis, and from A, project up, and where that crosses the y-axis, I've now found B. B connects down to C. That's the first part of the question there. I'll label this as O, like they have in the sheet, and there's B. Okay, first part of the question completed. Okay, second part of the question. Draw the elevation and end view orientated as shown and complete the trimetric projection. So to start that then, what we're going to do is I'm going to start setting up for my views. Okay, so to start setting up for the views, you're going to need your compass in a second. Just get my compass ready, so I have it here. Okay, and I'm going to start off first of all by extending out my x-axis, just lightly. And what I want to do then is, by extending out the x-axis, I'm going to project perpendicular to that and then extend out the A and the B point from my scalene triangle. So extend those out as well, so a little bit of sliding set squares here. Now what's very handy here sometimes is an adjustable set square, if you do have one. Okay, so I've done that there now. All I'm going to do is I'm going to project out a line parallel to AB, so rotating back around this way. It should be parallel to AB there, just slightly off. So I'm going to sort it out there. There we go. I'm going to extend out there, and about here I think would be appropriate. Maybe a little bit further. Okay. So that line there is parallel to the AB edge, and the lines that projected out are perpendicular. Now, what we want to do is we want to set up a semicircle, and we're going to bisect this line here. So, at the end of that line, I'm going to bisect it. Once I get that bisected into the middle, I'm now going to do a semicircle. Perfect. And what helps me is that semicircle, where this point here, by extending out the x-axis, where that cuts the circumference of the semicircle, that's going to provide me with my 90-degree axis to draw in my elevation view. So from there, because we know that any angle or any triangle inside of a semicircle will be a right angle. So that angle in there now is at 90 degrees. Okay, so I'm actually going to start by drawing in this view here. So just looking at the information that it gives us. So we've already created the semicircle. We've got this 90-degree angle inside here. We just have to draw in this guy. So on my vertical height line, which is this one, I'm going to measure up to heights of 25, 25, and 10. Because that's going to give me these heights here. Okay, and then we've obviously got a semicircle inside here that has a radius of 50. Okay, and the start point here. So I'm just going to start by putting in the height lines, and you can see the center point is actually right here where the semicircle point is on, right there. So that's going to be helpful for me, and I can put in my radius 50 semicircle. So zooming out there again, I'm going to measure up my various heights. I had 25, 25, and 10. So from the top, that adds up to 60. 0 to 1, there's the 10, plus 1 plus 25 would be 35. Okay, so those three little height marks there that I'm after putting in, I'm now going to project parallel to this line here, which is representing my ground line. Consider it your XY line. So this is the elevation. So those lines all went that way. That's perfect. And now what I'm going to do is, with my compass, I'm going to do a radius 50. Just mark the 50 from the center point here. This is our center point right in there. I'm going to mark the 50. And start putting in my semicircle. Actually, it's quite good. I'm just going to get this heavy in. Curves are hard to heavy in with the compass sometimes. Okay, now that I've that done, what's helpful to me there is where we see the semicircle. From this point here, you can see this line here runs up, okay, parallel to the vertical axis line, okay, runs up, and it's going to give us this line here, and it's going to give us that point, and then we can see obviously the distances that we have to go, because from there it's going to be equidistant. This distance here is going to be equidistant on the opposite side to complete this question. So to do that, I'm going to set up my set square on my vertical axis line, which is there. Sliding set squares, I'm going to go to the 50 mark, that one goes to there, and on the opposite side, I'm just going to move my set square here, this way. And there we go, it's the exact same at the opposite side. So to complete this question now, I'm going to start other pencil here. Where's it gone? Where's there? Oh, here we are. I'm going to go a little bit darker here. So from this point here, that point there will connect into here like this. Likewise at this side. I forgot to put in my vertical line. I'll put that in a second. Going up through the middle to represent the table tennis net. Now, all I'm going to do here is take this distance from here to here with my compass, mark that out at the opposite side, and that will tell me how far I go there to heavy in. So I'm happy with that. And then just to finish off the question, I say finish off the question, sorry, finish off the elevation. I'm going to go parallel to the vertical axis line. Once again, just have to move my set squares this way. That'll go up there. What's helpful about that then is that can represent table tennis net. Okay, so there we have it. There is the elevation completed. Now what we're going to do is we're going to move on over here to the end elevation. So the same steps are going to be required, and obviously just putting in the measurements then to complete the end elevation. So I'm going to start off this time by just going extend out my z-axis, and then parallel to that, extend out C, slide it up. I'm going to rotate my set square over to this side, which will allow me to extend it on. Okay, and then that there, set square down, I can rotate perpendicular again, and I'll extend it out as far as here, I think. Okay, so there's that line. Now what I want to do with that line, that is going parallel to the to the BC edge on the, right there, just adjust that, the lighting. Now I want to bisect that line again, once again, to get our semicircle. So pick a distance greater than halfway. Get the midpoint of that line, which is in there, and then using our compass, I'll always just check. There we go. I've got my semicircle, and now with my semicircle got, I will put in my vertical axis and my horizontal axis. Okay, so there we have it. There is our vertical axis, and essentially, I should have put this in a while ago. This line here is representing the y-axis. This line here, in this case, is representing the x-axis, and this line here, this point, is a point view of the z-axis. Okay, on this side, this line once again was representing the y. This line in this case is representing the z, and this point here is a line representing the point view of the x-axis. Okay, so just to complete that question, what we want to do now is looking at the measurements on our sheet. Sorry, there, sheet just went down on the ground. We're going to take, we've obviously got a 70 width, and then we've got the vertical height of 50 and 10. So that one is much, much easier than this one to draw. So Measuring out from Z, 70 millimeters, and then 50 and 10, so 60 altogether. I'm going to measure up to 50 as far as the 1. There we go. Now, using my ground line here in this case, horizontal lines, and then rotate it. I should be perpendicular, vertical. So it's just the case now, heavying in the information. So as you can see, starting to build up the question now. Okay, so there we have it. We've done the elevation, we've done the end elevation. All we have to do now is we have to complete the trimetric projection of the table tennis table in here, and what it will end up looking like is something like this. Okay, so to start off with, I'm going to leave the curve till the very end, but what we're going to do is we're going to do the tabletop and we're going to do the net as well in red. That makes the most sense. Okay, the tabletop and the net. So to do that, all it is the case of is doing a series of sliding set squares. So everything in this view here, the end elevation, is going to project down parallel to the z-axis. Everything in this view here is going to project down parallel to the x-axis. So I'm going to start off with my tabletop, which is this point, and then the table net, which is this point and this point. So it's only 4 points in this view. So go on, line up with the z-axis there. I want to be 100% on the money. What often lets students down in these questions is their accuracy. So sliding this one across, so from here all the way down, just about hitting the top point there, all the way down. Hopefully hit the top one, just a little bit off, so I'm going to rotate my set square around, and that'll allow me to go up. Okay, so those 4 lines have come down from here. Now I'm going to project these ones down. So it's going to come from this point and this point, because they're the 2 points at the back edges and the front. Okay, and then this point and this point, which will give me the table tennis net. So this time I'm projecting down parallel to the x-axis. So I'll start off by lining it up with my x-axis. Okay, and I'm going to start off with this one here. I'm going to go down as far as there, probably went a bit too far. Then I'm going to get the top of the table tennis net. It's probably far enough. I'm going to move my set square around. I'm going to get the bottom of the table tennis net. And then all the way along, you can see here I'm just going shorter than the line of where I need it to be. So just move it this way. Actually I have to move it past it first. Just go past first and then I'll move it up. There we go. Just a little bit of manipulation with the set squares. Okay, so to figure out the tabletop goes from here to here. So they're the end lines going in there. So I just have to find obviously where it's cutting through this line here. So look, if you follow that across, it should meet technically in there. My accuracy is about 1/2 mil out, but I'm okay with that. There's another one. Now I'm going to find down this side. So as this comes down, it's actually here. Just make sure I have the right one. Yep. And then obviously up along here, and there's the other one. So there is our tabletop. I'll only have in 3 lines here to start with. There's 1, 2, and 3. I will have in this bit just thinking just about here and here. The reason being is because the table tennis net has to be put in next. So to get the table tennis net, this one here is going to follow down, but where is it going to start? It's going to go down here, and where it's going to hit on the edge. So just make sure I have the right one. Yeah, it's hitting right there. Okay, and that will go up vertical, and it should technically hit there. And this will be a true test of your accuracy, just to see what your accuracy is like as we projected our points. See how close I am. It looks like I'm pretty close. I'd say I'm going to 1/2 mil off, but If that's on an exam day, I'm pretty happy with that. So there's that one, okay? And then I'm going to check the back edge here, and it should match up with this one above it. There we go. Actually quite happy with that. And it's just a case then of I can now heavy in, sorry, table tennis navel before I finish, or the table tennis net before I finish the table. And now in axonometric projection, you do not have to put in hidden detail. So there's the tabletop. Now what we're going to do is we're going to work onto the legs, okay? I'm going to start by doing the arch first, okay? Just by focusing on the front arch here, okay? And what we really want is just a series of points on it, okay, to help us out, okay? So really we've already got a number of points. We've got this one, got this one, we've got the top one, this one, and this one. So how many additional points? Should zoom in there. You can see the ones that I've marked there. How many additional points would I need? I definitely do need, I think, one more in there, and I probably need one in here. Okay, and because I have that one and that one, then by alternative, we're going to be using a series of horizontal cuts here. I'll have one out here and one out here as well. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9 points. So, as I said, we've already got this one, this one, this one, this one, and this one. It's just simply a case of finding 2 more. Okay, so there was a height here. I'm going to roughly guess. It doesn't have to be an exact science. Often at junior cert you go 30 degrees, 60 degrees, sorry. Should zoom out there. I'm going to pick one about here. I'm going to pick another one in here. Okay, now I'm going to label all those points. Get my barrow there. I'm going to label them with letters. Actually, we'll go with numbers. So 1, 2, 3, 4. This point here at the top, which we already have, is 5. And to get 6, 7, so I'm going to go parallel to this line here, my other set square. From the 2 and from the 4, okay, that one there, point, so there's number 6, here's number 7, and then I've got number 8 here, and then we're down to number 9. Now, I've got all those points on my elevation. I have to now find them on my end elevation. So that front surface here is actually this curve. So if you imagine number 1 and number 9, number 1 is here at the front, then number 1 will go up to number 2, then to 3, 4, 5, then back down to 6, 7, 8, 9. So 1 and 9 actually will share the same position. Okay, so it's simply a case now we have to plot the points for the other ones. So I'm just going to use my compass here to take the vertical heights. Now the easy one for me to take here is the 5 is already done for me actually at the top as well, because the 5 is going to be up there. The easy one for me to do here is the number 3, which is up a height of 25 already, and the 7. So it's up to that height there. So I'm just going to take it here. Remember, it's the vertical height. I wouldn't take it from here and just guess it. I'd take it from the outside where the height is the exact same, and just then come over here and mark that up. And at that height, I've got 3 and 7. Okay, and now it's a case of finding 4 and 6 and 2 and 8. So the way I would do it here to be 100% accurate is I take those heights in here from the middle, because 2 and 8, when I projected them across, I can take the vertical height from in there. 100% accurate. So there's the 2 and 8. And then I'm going to take the height for the 4 and the 6. There we go. So I've got 2 and 8 and 4 and 6. So it goes 1, 2, 3, 4, 5, 6, 7, 8, 9. Now it's simply a case of projecting them down and projecting them across this way to figure it out. So like we did with the tabletop. But obviously we're getting onto a curve here, so it will be a little bit more complicated. So starting off, I'm going to go out to a line that I've already used to project with, and I can just go parallel with that. So I'm going to go down as far as the 1, down, onto the 2, onto the 3, 4, the 5 is already brought down for me, 6 is just up here. At this point, I'm actually going to start sliding it. I'm going to bring it back down here. I'm just going to start sliding it this way. Just moving my set square around. So work there 9, B8, it's just about there, and the 7, and I think 6 is done. Extend the 6 a little bit further. There we go. Okay, so all these ones have been brought down. Now let's just do the same at the opposite side. So parallel to this line, for 1 and 9, it looks like it should go far enough. Extend it down. 2 and 8, 3 and 7. Just bring them down as far as you think you're going to need them. Okay, the 4 and 6 I'm not reaching, so I'm going to slide my set square around, keep them held in place. We're after 4 and 6, and finally 5 is already brought down. Okay, so it's simply a case now of plotting our points. Just the lighting there. Okay, so to plot our points, I'm going to start with number 1 and number 1. So number 1 and number 1 are going to meet right here. So there's number 1. 2 and 2. It's going to be right here. Then I've got 3. Just going to make sure so it's down here. Yep. So after going to all this work, just be careful that you don't make an error. Okay, so there's 3. 5 is right up here, so I'm okay with that. And then I want to find 4 as well. So 4 comes down along this line, so I'm going to just keep my finger on that and follow it down here. Okay, so I want to make sure it's just this one here. So there's my 4. Okay, so I have 1, 2, 3, 4, 5. Now I'm working back down, so 6 is just out here. It's going to be on the same line as the 4, so I can use the kind of 4 now as a guide, and it's out as far as the 6 here. Yeah, so there's my 6. Then I'm on to the 7, which is on the same line as the 3. So follow it down. And then onto the 8. Same line as the 2. Follow it down. And finally the 9, which is down here. Okay, as you can see, the curve's starting to take shape there now. So all we do is we freehand it in. So I'll do it ever so lightly first, try and be as smooth as you possibly can. Five, 6, 6 into the 7, down to the 8, and the 9. And just with my pencil now, a darker pencil, going to go over that. Try and do it in 1. See there, try not to make it hatchy. 1 continuous path. There's the 6, 7, 8, and down to the 9. Okay, so now we've got the curve at the front of it there. All we have to do now is we'll have to get the curve at the back as well. So rather than going through all those stages, we could bring the points on this side here, because there's obviously a curve at the back, bring them over and project them all down. But there is a quicker way, because we already know the width here. The width will be the same here. So let's say I wanted to find the points at the back. I can take the distance. I actually think, sorry, it's not that distance, I apologize. Let me just confirm here. So the first point at the back would be, if I was to follow this one down here, because we already have a point, if I follow this one down, all the way out here, there's our point. I was going to take the distance from here. That would have been a big error, apologies. I'm now going to take the distance from here. That's the distance I meant to say. So from here, right there, that distance there, I'm going to take that and mark it from each one up. So I've got the distance at the back, let's say for 1. Now I want to find 2. So I'll just move it up to 2. 3. Up to the 4. The 5 should already be done. There we go. 6. Be in there. 7 will be in there. 8. Not that I need all of these, but just to give the idea. 9. Now, I'll explain why I got the most of them. I'm going to put in that curve once again, ever so lightly, and through all the points. So we'll go all the way up to there. And then from there out to the 8, or the 6 I should say, 7 to the 8. And what's helpful here is it does actually come down there a little bit right at the back. So, to actually heavy that in now, there's that bit I'm heavying in, and I'm just heavying in that little bit down there as well. Okay, so there's the curve, guys. What we have to do now is move on to just the little stanchions. So if I just bring over the question sheet there, we've got this little guy here, this one here, and that little bit over there that we have to complete. Okay, and we've got the trimetric completed. So to find those, one of them, look, it's already connected to 3, so we just have to find that point up there, and one is connected to 7. So we technically have 2 points. So this one and this one are the points we want to find, and they're on the top surface. So it's simply a case of just using sliding set squares and projecting those down. So it's on the top surface, at the front and the back. So that's helpful to me there. I've got this one here and this one here. And if I keep sliding it up, I'm actually have to go across this way now again. There's that one at the back. Okay, once again, heavy in, so 3 connects to there. And in this case, it would be from this point up to here, but I'm just going to heavy in that much. Okay, so it was connecting, just to put it in lightly there, but I only heavy in a little bit at the bottom. And the exact same at the opposite side, 7 connected. Okay, just have a quick look at this. I'm pretty sure that's all the detail. Now, I don't think we have to put in the kind of line running down the middle. If you wanted, you could get the midpoint and just project the line down, but I don't think that's required. And the next little bit in the question, so I think that's actually, sorry, part A is done, part B is done. Now, part C, they love to throw these questions at the Leaving Cert higher level students, okay? Determine the true length of the diagonal along the top surface of the table. So what they mean by that is, if you look at the top surface, you've got 2 diagonals. You've got the diagonal running from here to here, and you've also the diagonal running from here to here, which would technically be the same distances if you were looking down from a bird's eye view. But really what they want is, they want us to get that line. So there's a couple of ways you could go about that. All right, lots of students might make the error and they'll just come along here and they'll just go, oh, well, that one looks shorter than that one. So they just come along like this and go, line like that, true length. That is not correct. What we really need to do is we need to actually draw the true shape of the top surface, okay? And the only way to draw the true shape of the top surface is, it's a rectangle. This line will be the same length as this line, and this one will be the same length as this one. Excuse me. So, all we need is the lengths for those lines. Now, do we have those lengths? Yes, we have the width of the table, which is going from here to here, which is 70. And we also have the length of the table, this bit here, which is in the elevation, which is this distance here. It didn't give it to us, but that is the true length of the top of the table going from here to here. So the easiest way I'd actually find would be is to take the width from over here and project it on. And it's like we take the table and we flip it up. Okay, and that's the idea. So we're going to take the width, which is 70 millimeters from here, that distance there. I'm going to come up to our table here, just almost going above my sheet there, so apologies, just gone a little bit above the Y. And I'm going to extend that up. Now, I could draw in the whole table, it'll go slightly off my sheet, but really we only want the diagonal, so we only want the triangle. Now technically, I've got one side, I've got the long side, and I've got the short side. And we know if we connect, look, long and short, and we connect them opposite to each other, that will give us true length. So if I connect there to there, that line there is the true length diagonal. Really, really easy, but what they're trying to do is test your understanding of a real world scenario. Okay, that's all. Okay, so there we have it. Determine the true length of the diagonal along the top surface of the table. Okay, guys, there, guys, was the 2021 Leaving Cert DCG question based on the topic of axonometric projection Nice little question, obviously testing on your curves, your setup of a question, and it was specifically a trimetric question where we had a scaling triangle here where all the angles are different. Okay, but if you understand the rules of simple isometric, when you practiced in axonometric, the isometric, all the rules are the same. They just have to be applied across differently, obviously, when you have different angles inside here. Okay, that's the question done there, guys. I hope you found that helpful. Okay.